Okay, this is recording number 2. Let me just get back to my question or my issue before from the first module. It didn't actually say what the new mean was, but if you turn to page 241, the idea is after people eat these blueberries, it actually says, what if the new mean is 92? And the idea is if the normal mean is 80 and the new mean is 92, hopefully that difference of 12, we want that number to be large. That's called the treatment effect. So when people eat the blueberries, we hope their score on this neuropsychological test is very, very high. So the larger the numerator is, the better off we are. And that's called the treatment effect, is what the numerator is. So the denominator, the next part of the lecture here. So the denominator is going to take a little more time to kind of go through. What I'm going to ask that you do is go back to page 203 of your book, and I'll go over more information on what the denominator is. It's actually called the standard error of the mean. So the first question I can ask you, with a standard error of the mean, do you want that number to be large or small? Well, hopefully you say you want that number to be small, because anything that measures error, we want a small amount of error. So consider the following situation that I have on the agenda. This is going to be a little game. Hopefully you'll understand this a bit better at the end. But let's just say that I have a big population out there, and the big population is not a big population. The big population, let's say just for the sake of example, has 4 scores in it, 2, 4, 6, and 8. Now, when I do hypothesis testing, which is the new thing we're going to get into here, what we do when we do hypothesis testing is we almost never have the whole population. Instead, we have a sample. So let's just pretend, for the sake of argument, that I have a population of 4 and that I decide, just for proof's sake, that I will get all the possible samples with the 4 when n equals 2. So let's try this out. And the book actually follows this precisely, that if you actually take the population with the 4 scores, 2, 4, 6, and 8, and you get all possible samples. If you turn to page 204, the first sample, so let's say you go into that bag and you grab a number. Let's say the first number you grab is a 2. And then you put the 2 back in and you grab a second number. The second number is also a 2. So the first sample might be the numbers 2 and 2. What is the mean for that sample? Well, the mean is also 2, correct? If you follow that on sample 1. Let's say for the second sample. Let's say for the second sample, you have sample number 2. You first draw out a 2, and then the second number you draw out is a 4. What's the mean of that? It's a 3. The third sample, you grab a 2, and then let's say you grab a 6. The mean of that sample is 4, and you can actually get a total, if you look at that table there on 7.1, you could get a total of 16 different samples. So if you have 4 people in a population, large N equals 4, and you actually get all the possible samples when N equals 2, you can actually get 16 different samples. So the next thing the book actually does in figure 7.2 is it actually makes a chart of all the possible sample means. And to figure out all the possible sample means, just take a look in that first column with the sample means there. So for the first sample it was a 2 and 2 and the sample mean was 2. How many sample means of those 16 will you get a sample mean of 2? Well, there's only one example of that. And so in figure 7.2, it actually makes a little graph and shows that you have sample means. The sample mean of 2 occurs 1 time with the 16. How many times do you get a sample mean of 3? Well, you can get a sample mean of 3 if you have the 2 scores of 2 and 4, or the 2 scores of 4 and 2. So there are 2 examples of 3. How many times in those 16 can you get sample means of 3? Well, there are 3 occurrences of that. If you look down the sample mean column, there's a 3, 3, and a 3. So it's 3 times there. How many times do you get a sample mean of 4? Well, there are 4 occurrences of that. Then if you get a sample mean of, actually I did it a little bit wrong, 2, there is 1, 3, a sample mean, there are 2 of that. For a sample mean of 4, there are 3 of that. For a sample mean of 5, there are 4 occurrences of that. When the sample mean is 6 in this little game, there are 3 examples of that. For a sample mean of 7, there are 2 examples of that. And the only example of getting a sample mean of 8, when big N equals 4 and little n, your sample equals 2, is when you draw out an 8 on each score. So there's only 1 occurrence of that. So that figure 7.2, is kind of forming an interesting distribution. Now, if I asked you what kind of shape would that actually look like, in statistics we really only have one shape. You know what that shape is? The shape of this situation is kind of the shape, if you draw out a little curve, would be of a normal distribution. The other question I would ask you here is the following. What is the mean of the sample means? What is the mean of the sample means? So if you took that whole curve there, could you figure out what the mean of that distribution is? Hopefully, you could look at that just the way it is and see that the mean of the distribution of sample means is 4. Can you actually see that just a little bit? 4 occurs the most frequently. Now, I'm wondering if anybody can tell me why that should actually make some sense. Why the distribution of sample means, why the mean of the distribution of sample means should be 4. Well, what you have to do to figure that out is if you turn back to 203 and look at the original population. What did the original population have for its scores? Actually, did I say the mean of the distribution of sample means should be a 5? I don't know why I keep saying 4. The mean of the distribution of sample means is a 5. If you turn back to page 203, can you share why the mean of the distribution of sample means should be 5? Well, look at the population. What is the mean for the population? The scores for the population were what? 2, 4, 6, and 8. What is the mean of 2, 4, 6, and 8? It is indeed 5. So if you actually have the whole population, and this is kind of the take-home point of this Looney Tune activity, if you actually have the whole population, you have 4 scores there. The mean of the population is 5. And when you actually take that population and then form a distribution of all the sample means when n equals 2, you actually get a normal curve, number 1, that's good news for us, and the mean of the distribution of sample means actually equals the population mean. Whew. I know I've gotten awfully theoretical on you here, and I hope I haven't lost too many of you here, but that's the main point of this little exercise per se. So hopefully you understand that. Try to write some good information. Come to class with some questions about this, and hopefully this works out for you. Thanks. Bye.